a look at what I can improve from here. First, instead of the byte blocks, I'm gonna try to do this on the main compress. Okay, compress file name, the target file name, file size. Okay, this I'm gonna change because now all the output of the program prints the datetime in front. So I like to do this. File size in bytes. Okay. So this is the case where we try to attempt to load everything to memory. Ring file bytes to memory. So this makes the bytes nice. I could extract those two lines to a print method, but that's not much. Or even those three. But I'm interested in using this one, so I don't want to overcomplicate it. This could be extract to one line as well, like validate file size. And byte read, but it's not much as well. I think it's clear. It is not. I think it's not worth. And here, yes, here I extracted it to the compressed by blocks. So what I'm doing in here, I calculate the bytes compressed. Okay, I make it nice with a string formatted. Okay, I get the units that are more suitable for that, like gigabytes, megabytes. And then okay, so basically this is printing stats of the files after having been compressed. So I think that if I get this parameter bytes compress, I can do the rest of the things. It looks like bytes compress and byte read is the only thing I need. Size compress. Yeah, okay, I'm gonna extract this. I don't like much the methods that print, but I'm gonna do it for the clarity, for the sake of clarity of the code, and in order to make it more easy to test as well, to provide more maintainability. So I'm gonna refactor. I'm gonna extract method. Okay, so method name, that will be print stats of compressed file. No, it's not a file yet. Is block of memory of of compressed data. Okay, and what I need is, okay, I don't need by compressed. I don't need this because I could calculate. So okay, let's do a bit different. Let's refactor this because I don't want to pass the bytes compressed to the method. I prefer to pass only a primitive. It will be okay to do it, but I prefer refactor, okay, refactor extract method. I prefer this way. Okay, okay, bytes compressed, byte read, and OD. OD, I don't need OD. OD is an alias that I create of self.o underscore datetime utils in order like to print it more nice, or to instead of having o underscore datetime utils, sorry, dot p, I can do o underscore d dot p. So this I don't need. I can reproduce inside if I want. And yeah, that's it. Okay. All right. So I'm gonna go here now. It doesn't know OD, and then I indicate OD itself or daytime. Perfect. Nice. So now we have extracted this. Which basically prints, having these prints, okay. Lovely. Go back to okay. So bytes compress, file size, bytes read. So what here I can say here check final bytes, for example. Well, this I don't want to, in order to save few lines to like to divert the functionality. This wants to make sure that the original file has not changed. Because the file size we read at the beginning and the byte reads is bytes that we have been reading until we cannot read more. So it's possible that has changed. In any case, this is very... We could extract this, but I'm not worried about that. So byte compress, this is more like some rules like... This makes more sense to validate. I'm going to extract it. Refactor extract method. So I will call it validate compress size or exit. We get the byte reads, we get the bytes compressed. Okay, that's fine. Good. So if it doesn't match the rule, this will exit. So now we have this method, and the rules are okay. If the size of the compressed object is 0, that's no good, and we are gonna interrupt the processing here. If the size of the file compressed it's bigger than the file or the original file, Obviously we don't want to attempt to write it. Also, we will not be able to write it because there will not be a space on the disk. As this tool attempts to compress files when there is no space on the disk. So we cannot write any space bigger than the file that we will delete. Okay, so what I'm gonna test is this. Well, I'm gonna run the test first to see that everything that was working still works. Okay, cool. And this new method obviously will not work. It's not being tested. So we are gonna test this. So this is easy to test because it's very similar to the things that we have done before. So that's gonna raise an exit. We could also use the fixture to check the text that is printed, but in this case I'm happy enough with the exit. So okay, def test. This will be the happy path, the okay, and then we have okay some file name. Well, we don't need a file name here. Do we need? No, we don't need this. We need this. Okay, this we need, but not the mock. Okay. So we have this, and then basically we will have something like this. And what we will call in here is validate compress size or exit. No. Let me undo 1 second. Verify. Okay, so I should use the same. Okay, I should use the same name everywhere. So what I'm gonna do, I'm gonna call verify instead of validate because previously I was using verify. So just to follow, I don't care if I call validate or verify, but I want to use always the same criteria. So I'm gonna do a refactoring here, and I'm gonna call this verify. Verify. I'll do a preview to make sure. Okay. Okay. I think that this already exists with 2 different signatures. Is that possible? Let me see. Oh, that's the test. Okay, name doesn't matter. But this is wrong. Compress in line 476. This is expected bytes compress and bytes read. Okay, you see that I'm doing this in real time with dubs in real time as well. Validate compressed size or exit. Okay. So what the hell I'm doing here? On test 141. Oh, this is the new thing. Also, I changed the name, but I didn't change. Oh, my bad. My bad. Obviously, I have to pass these the right parameters, which are bytes compress and byte read. All right, so it's safe to do the refactor to verify. Okay, verify, but this signature is wrong because I pasted from the example of another method that was the real problem. Okay, so and what I use is this. Okay, and I'm gonna say it has to be okay. This will be okay. So bytes compressed. Let's see. Let's say they are like this, and byte read. Okay. So all of these should return no no wrapped and should return no error code. But should return verify compress size. I think this doesn't go there. I think it's not return on here. Okay, mental note. Okay. Okay, so what I'm gonna do here, I'm gonna return as success. I could have returned hard code directly, but I like to do this way. Okay, because if I watch a return true, I don't know what it is. But if I have a return be success, I know that is a condition that work or didn't work. Okay, so I prefer using variable names rather than magic values. Okay, so what we are gonna do in here is to catch that boolean, and the non-happy path will exit, and this code is the code that will be executed. But in the happy path, it will not exit, and we will have success. Sorry, assert b success is true. All right, so I'm gonna copy this for the non-happy path before I delete some lines. Not okay. So for the not okay, this really we may have a none in there. I'm gonna make sure that we have. Well, see, that's no. We are not going to compare b success because we are like catching this rise exception. So what I'm gonna do is like, okay, validate that we have system exit and we have error code 1. What is this telling? Too many blank lines too. Where body? Really? No. something weird happened because one line was okay and was telling. Sometimes by charm is slow processing some things. Okay, that's fine. This is the case that will fail, and we expect it to fail, for example, if the bytes compressed are bigger than the bytes read. So this is what I'm This is what I'm gonna delete. All right. So, and this I have been copying, but we don't need argutils. As you see, I have a lot of code repeated, but in the tests, it's better to repeat the code rather than reusing, and then getting inadvertently fake results. So, okay, let's go for it. Let's see what we have. I want code coverage. Okay, something broke. Failed. Test 137. Did not raise. Okay. Yeah, that's true. That's true. We don't expect it to raise because that's the happy path. Okay. Again, run PyTest with code coverage. Okay. So we have covered. Okay, we have covered. There is one case we have not covered. Okay, the case where byte compress is 0. So we are gonna cover this case as well. So as you see now, I can add another method to check that, or I could just do, for example, do bytes compressed is 0. Well, that I can remove, and then I can say execute again, and it will work, and we will have that covered as well. Okay, but the thing is that, okay, we are very scarce with the tests. So what I'm gonna do is something like I did in here, where I assembled an array for testing many cases. So I'm gonna do the same in here. So I'm gonna assemble an array for the success case. So I'm gonna call it array test success, and this will be an empty array composed by several lines, several arrays inside that will have, for example, first the byte reads. We will have the first case will be 2096, and the bytes compressed 1024. And I'm gonna do some other cases. Okay, so for example, okay, and the bytes compressed, it's 1 byte. I don't think we can have a compressed file of 1 byte, but this is a case that should work. It should pass our test. So we are gonna have, for example, 1024 and versus 1 byte less. Let's say we have the same. What happens if the compressed object and the original object has the same weight? I think I did not cover this. So, well, let's add a to-do here. verify, and let's finish this. Whatever and whatever, smaller, and a very big number, and so number but not that much, and again a incredible huge number versus a really small value, and 150 and 100. All right. So let me verify the case I told you before. We are verifying the size. Okay. We are only verifying that the size compress is bigger. But honestly, if it's the same, if it's exactly the same size, doesn't make any sense to compress it. So I'm gonna change this on my program now. So I'm gonna say if the bytes compressed are bigger or the same, compress size is bigger or equal. That should never happen, because if we try to compress something compressed, it results in a bigger file. But okay, if the size is the same, we don't want to do all this process. All right, and I'm gonna change the change log to express this. Okay. If the compressed file is the same size than the original file, we will not delete the original and write the compress. We will abort, cancel. Cool. So we come back here. That's fine. So this case will fail then. This case will fail. Okay. But it's fine, because I'm gonna reuse this on the other case. I will keep this. I'm adding a note for myself to do work in progress. Keep this. Okay. But in here I remove, because that will make it fail, and I want all of this to work. So now what I'm gonna do here is a for sizes, for array sizes in array test success, then do bytes compressed is array sizes 0, and bytes read. Oh, sorry, I did the opposite. The read is the 1. The compressed is the 1, and read is the 0. Sizes 0. And so for logic, I prefer 0 to be before 1. This like that, and this like that. So now this makes no sense anymore. So now we will be validating 1, 2, 3, 4, 5, 6, 7, and we can very easily add more values to here. So, I see that this is a typo, and it's a typo as well. Okay, so now this has no effects. So basically what I'm gonna test is that this works well. Okay, perfect. So we have been testing all those cases. Perfect. So now I'm gonna do the same for all those cases that fail. This has space with no printing, and more lines like this will be printed in here, which is okay. So well, basically it's the same. So let me copy. Then this is not necessary anymore. And this yes, this not. This has to be okay. And then we will be asserting here every time. So that should be okay. Bytes compressed. Okay, nice. Okay, so this I can remove now. This not. And this I can remove. Well, I will keep this. 3000. Okay. So cases that will break it will be. Sorry for these typos, but I have the cable of the microphone that is in the middle of the keyboard that moves often and makes me make typos. Okay, so we will do like this. Most of it will be bigger compressed than read. It's the opposite case. And in all of those cases, we should have the same fail we had before. Okay. Okay, exactly. It has run each of those lines. Perfect. And when was bigger or equal, okay, perfect. I saw something that I didn't like, which is that normally for consistency, everywhere for me the first parameter is the byte read, which is the original thing that we read from drive, and the second one is the compress, like chronological. I like to create like this consistency on my code, like the first objects or the most important go first. And I see that when I use the refactor from PyCharm, it created the parameters in the opposite position that I would normally do. So what I'm gonna do is see the usage of this fin usage. Okay, and if it's not a major trauma, I'm gonna do a refactor of this. All right, perfect. So I'm using only in one place for the code and in two places for the test. Lovely. So what I'm gonna do here is I'm gonna swap. Okay, I'm gonna now fix the test cases. And to avoid problems, in the future, I will use the naming. And all right, bytes compressed, byte read. Funny enough, it has not updated. It still shows the old way, which is not anymore. You see, I click here. Oh, I changed the definition, but I forget. Okay, cool that I checked. Nice. Okay, so I was going to introduce a mistake. Bad. Okay. Naming the parameters, even if I change, it will not fail. but I don't want to leave things to the luck or to the bad practice. So okay, we change this. All right, almost there. Okay, so here we go. We have all the places and this Maybe conversation exit. What's that? Okay, bytes read, bytes compress. Okay, so now we have all the places replaced, and obviously I want to run the test to make sure that I have not screwed it inadvertently. So perfect. Okay. So now I'm happy, and I'm happy with the order of the parameters, and we have tested another case in the happy path and the not so happy path. So if we see the code coverage, oh, okay. I did not cover this one. The case where bytes compress is 0. So we are gonna cover it, and this will exit. So it's a case where fails. Not okay. Okay. So let's add another case. The original file may be whatever, and the compressed file will be 0. And this is a real case where, for example, if the system runs out of memory while we are compressing, the compressed object will be 0, and we will not continue. So we have to check that path. Okay, and if we see now, perfect, we have covered all this path as well. Cool. So nice. I'm happy with this advance.